Welcome back. Today we will be talking about the differentiation with power constant and sum rules. Let's talk about what is a power rule. So when we are talking about the power rule, we are saying we are trying to find the derivative x to the power of n. So the rule is drop n and n minus 1. That is the rule. So you can write it down, it can rhyme in your head. The derivative is simple, drop n minus 1, and n is nothing but the power. That is why it is said power rule. So derivative of the constant is 0. And when we are talking about the sum rule, we are saying we are taking the derivative of f of x and the derivative of g of x separately, and we are adding them together. So let's try question number 1. So number 1, it says y is equal to 5. 5 is just a constant, so answer is 0. Right? Because the derivative of the constant is just 0. For number 2, it says f of x is equal to 5 times x to the power of 18. Now, 18 is n, so drop n, then times 5x, 18 minus 1. And this is your derivative. And you can write derivative as dy dx or f prime x. So your answer will be 90 times x to the power of 17. So because 5 was already the constant, right? So constant will remain as it is, and then the power rule. Now question number 4 is example of the sum rule and the power rule. So we will take the derivative one by one. So f prime of x, so for the first one, the power is 4. So drop n, so 4 is already there. So 4 times 4 x to the power of 3. We will do the same thing with 5x. It is only 5 because x has the power of 1. And 1 minus 1 is nothing but 0. And you know that x to the power of 0 or any number or variable to the power of 0 is only 1. And the constant will give you 0. So if we clean this up, we will get this lovely answer. Remember, x to the power of 0 is 1. Number 6. Now we have n as the fraction, which is 2/3. So don't worry about the fractions. Fractions are just numbers. So we will do the same thing. Drop n. 5/4 is already there. So drop n, which is 2/3. X to the power of 2/3 minus 1. And remember, when you subtract the fractions, you have to make common denominators. So if we clean this up, we will get, and you can see 2 is in the numerator and 4 is in the denominator. So I can just write 5/6. 2 times 3, which is 6. 5/6 x 1/3. That is your final answer. Now let's try question number 8. Now x is in the denominator, 3/x cubed. So I can bring it up as a negative exponent. And we will do the same drill. F prime of x is 3 times negative 3 x to the power of negative 3 minus 1. So understand how to subtract the integers. It will be x to the power of negative 4, and because it's a negative exponent, we will bring it down. Let's quickly try question number 10. For question number 10, I can rewrite it because we have a radical, right, with the index of 4. So because it is the index of 4, I can rewrite it as negative 2 in the parentheses x to the power of 1/4. And then same drill, drop n and n minus 1. So x over 1/4 to the power of 1/4 minus 1. Remember, whenever you add or subtract the fraction, make common denominators. It can be simplified as negative 1/2 x to the power of 3/4. That's it. Let's try some more questions. But I can rewrite it in a simpler form because it's a negative exponent. You can bring it down. Okay. Now you can try 11, 12. They are on the same line. 13 and 14 as well. We have done those type of questions. Now let's try 15 because it has a fraction and the exponent is also a fraction, even though the drill is the same. So we write 2/3, bring n down, which is 3/2. So times 3/2, x to the power of 3/2 minus 1. And we will do one more time because we have two terms. 3/4, bring 3/5 down, x to the power of 3/5 minus 1. So let's clean this up. In the first one, 2/3 and 3/2, it will cancel out. So I will be left with x to the power of 1/2 after subtracting the fractions. And this will be 9/20 x to the power of -2/5. You can leave as it is, or you can just bring the negative exponent down to look a little bit neat. And this will be your final answer. Let's try 17th and 18th. So for 17th, it is 5c. So my answer will be dy dx is equal to 0 because c is a constant. So read the problem. They specifically said a, b, c are constant. So if I do dy dx, 4 is there. So bring 3a down, which is 12a, times, we have ax, so it will be a squared, x 3a minus 1, because a was already there, right? And when we brought 3a down, so we have two a's. Same with the b, 3b down, and c was there. So a squared, because 4ax cubed is 4 times 3a and x. And for the 18th, when you are bringing 3c down, it should be 3bcx. I forgot to write c, but that should be the answer. Thank you. Thanks for watching.